Hello, my name is Frank Silvera, and today I'll be discussing the Lab 6, which we used a 5-hour type timer to show a square wave on the oscilloscope, and we use this configuration. Uh, Initially, we were with this configuration, there is a resistor called resistor RB, and it is a 10 kilo ohm resistor that I measured to be 9.88 kilo ohms. We also had a capacitor, which I measured to 100 nanofarad capacitor, which I measured to be 94.25 nanofarads. Um, and I set that, uh, that we also used a 100 kilo ohm potentiometer for the position RA. And I specifically used the B and the C terminals. Uh, and I set it to 50 kilo ohms. And with these individual values, I calculated the frequency, and that was 219.015 hertz. Then after I built the circuit, um, I was I measured the frequency of the circuit uh, using an oscilloscope, and it was 210.526 hertz, which was really close to the calculated value. And then I calculated the duty cycle and the period. And the period is just the inversion of the or the reciprocal of the frequency. So that's how I calculated that. And then finally, again, I used the B and C terminals. We were tasked with finding out what would happen if to the wave if RA is increased and when RA is decreased. Now, RA is the resistance between B and C, since those are the terminals I used. And the way the resistance increases is the potentiometer is turned left, so the distance between the 2 points is greater. And the way resistance is decreased is that it's turned to the right, so the distance between 2 points is smaller. Um, and as you can see, I have two. Here's my circuit that's all configured, and here's me turning it left and right, the potentiometer left and right. And this is showing what happens when you increase and decrease uh, the resistance. Specifically, when RA is increased, so when the resistance is increased between B and C, or when the potentiometer is turned left, the square wave has a larger period and a smaller frequency. This means that the distance between each wave is larger as the resistance is increased. And again, you can see this in the video. Right here, it's getting larger. The period was getting larger and the frequency was getting smaller. And when the resistance between the 2 points is decreased, or when the potentiometer is turned right, so to decrease the distance between B and C, the square wave has a smaller period and it has a greater frequency. And you can see this as the wave gets smaller right there. That's just showing the relationship between the resistance between points B and C, the position of the rotation of the potentiometer, and the effect it has on the square wave.